Greetings, fellow mathematicians. We're going to go back to the problem of finding the equation of a tangent line, but now we have access to differentiation rules. And this is going to be a whole lot more efficient and faster. Now, your equation for the tangent line, which is basically point-slope form, we have it as y minus f of a. F of a is the y-coordinate of your point, and that equals f prime of a, the derivative, which represents the slope of the tangent line, times x minus a. So the only change, we're replacing the y-coordinate with f of a and the slope, m, with f prime of a. We calculate slopes of tangent lines now in calculus with derivatives. Now previously, you used the limit definition of the derivative to calculate the derivative, but you don't want to do that at any point moving forward. We're going to use differentiation rules. So we have two quantities to calculate. We're going to need to calculate the function value, and here that would be f of 1, and we need the derivative, f prime of 1. So let's do the easy part first. I'm just going to write the function down, f of x, which is x squared plus 1. And we're going to need the y-coordinate. So just go ahead and plug in 1 for x, and we get f of 1. It's going to be 1 squared plus 1. That comes out to 2. All right. Next, now we're going to calculate the derivative using differentiation rules. And here, if that's your function, f of x, the derivative f prime, that is really simple at this point, now that, again, you have access to differentiation rules. Differentiate term by term, the derivative of x squared with the power rule, that comes out to 2x, and 1, which is a constant, that differentiates to 0. So that's it. Maybe 1 second to calculate that derivative. Now we're just going to plug in our point, x equals 1, to get the slope of our tangent line at that point. So if that's the derivative, we want f prime of 1, which when you plug that in, you'll get 2 times 1, which is the same thing here as the y value. We get f prime of 1 also as 2. And that's all the information we need. We're just going to plug that in here to the general form for the equation of a tangent line. Let me go ahead and rewrite that as y minus f of 1. So here we're using a as 1. So y minus f of 1 equals f prime of 1 times x minus 1. And if we go ahead and plug in our values, f of 1, that's 2. And f prime of 1, the derivative, the slope of the tangent line, that is also 2. Just make sure when you're plugging in here, the derivative, you always plug it in, the derivative, as a number. In other words, plug in your value for a to get a numerical value. I've seen many students plug in here the derivative as a function of x. So just be careful of that. If we just write this down, we get y minus 2 equals 2 times x minus 1. And that is an equation of the tangent line. And it's going to simplify nicely if you solve this for y, which you don't have to, but we're going to make a connection to the graph here. So the point on the graph, here we have the point 1, 2, x, f of x. So that point that we're finding the equation of the tangent line, it's at the point 1, 2, and it looks like that tangent line does have slope 2. It looks as if we're going up, rising 2 units, and over 1 unit. The other thing is this tangent line seems to be passing through the origin. The x and y intercept both seem to be 0 there. Now let's see if we can see that by simplifying this. So let me first distribute the 2. We'll get y minus 2 equals 2x minus 2. And notice we can add 2 to each side. And those subtract out. And what we get is y equals 2x. And that does seem to be the equation for this tangent line. It seems to be a line of slope 2 with y-intercept 0. So the sketch matches what we get from our calculation. Now this is a really simple but good example to go through in the beginning of your Calculus 1 course once you have access to differentiation rules, because it's going to allow you to connect what you're calculating to understanding it graphically. So here we have the graph of our function, y equals x squared plus 1, a basic parabola shifted up 1 unit, and at the point 1, 2, our tangent line looks like that, and it matches our calculations. So anytime you're asked to calculate an equation of the tangent line, see if you can visualize what this looks like. That might be simple if your equation for the curve is simple, but if the equation is more complicated, that might be harder to do. All right, there we go. Hope you enjoyed the problem. Again, from here, never use the limit definition to calculate derivatives. Start using differentiation rules. Hope you enjoyed the video. I hope you learned a lot. If you did, support the channel, like and subscribe.